All right, folks, let's do number 42. As it passes, ow, sorry. All right. Over the Grand Bahama Island, the eye of the hurricane is moving in the direction as 60.0 degrees northwest with a speed of 41.0 kilometers per hour. 3 hours later, the course of the hurricane suddenly shifts due north and its speed slows down to 25 kilometers per hour. How far from the Grand Bahamas is the eye of 4.5 hours after it passes over the island? Now, I did attempt to do this problem, and I wouldn't say I failed. I was mostly confused the crap out of me because you have a... Before we start, let's conceptualize this a little bit, folks, and show you to my thinking process. I know you guys just want the answer and everything, but like understanding and interpreting is everything. Now, I do wish they would word this a bit more differently because they say that at one moment, regardless of the direction, the speed is going to be 41.0 kilometers per hour, and then at some moment, which is 3 hours later, the speed is 25 kilometers per hour. So my brain was thinking this equation when I was looking at this problem. So I was finding the A as the change of velocity over the change of time, and we're presuming that when talking about A, we're presuming as this is going to be the vector. I was thinking in terms of vectors. Now that's not the case for this problem though. So it doesn't really specify that this has a constant change of acceleration. So that's the thing that confused me about this problem here. But anyways, regardless of this. All right, folks, let's solve this. This is going to be the x-axis, and this is going to be the y-axis. So I'm going to actually draw this. 60 degrees north of west, that's going to be right here. So that's going to be 60 degrees north or west. So I'm going to put, what color should I use? I'm going to use this color. Ooh, that's a nice color. So this is going to be 60 degrees north or west. Wait a minute. No, that's 60 degrees. Oh my god, I always get so mixed up with this. Okay, so this is going to be the position. I'm not going to think of this as a velocity vector, but we know that this is going to be 60 degrees right here. And this is going to be 41 kilometers per hour. So this is not the velocity vector. This is a position vector. I know I drew this a little mixed up, but I want to make this distinction. So the eye of the hurricane is moving. The eye of the hurricane is moving at 60 degrees north or west with a speed of 41 kilometers per hour. This is what I wrote down. So the eye of the hurricane is moving at that speed. Now it's going to move from starting at 0 hours to 3 hours. So from the position here at 0, the hurricane is going to move at a constant velocity when the acceleration is 0 meters per second squared. I wish they would have just stated that because so I wouldn't be confused. So I'm going to reinterpret this problem as saying, and it might not say it in the wording, but I will tell you guys, so you guys don't get mixed up as I did, is that the eye of the hurricane is moving in the direction of 6 degrees north or west at the constant speed of 41 kilometers per hour. And I say constant speed. So that means that what we're going to be doing is we're going to take 41 kilometers per hour and we're going to multiply it by 3 hours. So that's just going to say 41 times 3. So that's another way of saying that this is going to be 123 in this position. So this magnitude is going to be 123 kilometers. All right, folks. Now we're going to say, since this is going to be 123 kilometers in this direction, that's going to be a vector. 3 hours later, okay. 3 hours later, after 3 hours, the course of the hurricane shifts due north and its speed slows down to 25 kilometers per hour. So after 3 hours, in that brief moment, the acceleration just jumps up radically at the speed of 25 kilometers per hour due north. I'm going to treat this as the position vector, but I'm going to find where this is going to end up. How far from the Grand Canyon is the eye 4.5 hours after it passes this island. All right, so after 3 hours, folks, which is 4.5 hours difference, that means that we're going to take the 25 kilometers per hour, multiply by 1.50 hours. So we're going to do that. So we're going to take 25 times 1.50. So that means that this position here is going to be 37.5 kilometers that it travels due north. So 25 times 3 is going to be 75. Oh, wait, 1.5. There we go. Okay, beautiful. Okay. So now it's going to ask how far from the Grand Bahama is in the eye of the storm. So, so this is the Bahama Island, and the tornado goes here, and then it's going to magically go up at 7.5 kilometers. I don't think it would slow down. I mean, I don't think it would magically slow down with the 0.000 second interval. But I don't know how a hurricane works, to be honest. But anyways, folks, there's your components, folks. Also, so we're going to be taking this vector difference between that. So I'm going to take 123 cosine of 60 degrees. So the vector difference, the position vector, I'm going to call L, is going to be negative 61.5 kilometers in the I hat direction. And that's 123. Cosine is 6 degrees, so that should be fine. So I'm going to take 123 sine of 60 degrees plus 37.5. And I'm going to add them up, and the direction is going to be 144.02 kilometers in the j hat direction. So this should match up to the magnitude, but it's asking how far. It's not asking for the vector, but I do like to have the vector component first before I compute the magnitude. I don't know about you, but I like to have the vector. Pretty much gives everything away. So does this answer in my match? I'm going to check 157. So I think it does. So the magnitude of L is going to be 100 and actually let me just call it like that. So L is going to be the. All right, folks. So the magnitude of L is going to be 156.60 kilometers. So that's another way of saying that if this hurricane would move at a constant velocity, at whatever that direction that is, then from 123, oh wait, what was it, 41 kilometers per hour, and then another constant velocity at 25 kilometers per hour, then 4.5 hours later, the position, the difference of L is going to be that magnitude. All right, guys. Hope you guys enjoy. All right.